Good evening, dear students. Welcome back to the Engineering Mechanics lecture series. So, in the last lecture, we have seen the resultant of a force and how to determine the resultant of two forces using parallelogram law of force. So, today we will solve a problem on how to find the magnitude and direction of resultant of more than two coplanar concurrent forces acting on a particle. Let me go to the problem. So in this problem, I will read the problem. Three coplanar forces are acting at a point as shown in the figure. Determine the magnitude and direction of the resultant. So they have given three coplanar forces. So this is the diagram given in the problem. So this is the point where three coplanar concurrent forces are acting. So 200 Newton force acting at an angle of 45 degrees, 400 Newton force acting at an angle of 30 degrees and 600 Newton force acting at an angle of 60 degrees with the horizontal. Now you have to determine the magnitude and direction of the resultant. Determine the forces, horizontal component of all the forces. That's the step 1. Resolve all the forces horizontally. Going to the 200 Newton force. If you resolve this 200 Newton force into its horizontal component, it will be 200 cos 45. The force will be acting towards the right. So it will be acting like this. When you resolve the 200 Newton force horizontally, so this force will be acting towards the right and this will be 200 cos 45. Since the force acting towards the right is taken as positive, so 200 cos 45 is taken as positive. Next, if you go to the 400 Newton force, if you resolve this force horizontally, so this force will be acting towards the left. So this is 400 cos 30. Since it is acting towards the left, you put a minus sign here. So minus 400 cos 30. Next, if you go to the 600 Newton force and if you resolve it horizontally, it will be acting towards the right and it will be 600 cos 60. Now if you sum all these three forces, you get the horizontal component of the resultant, that is sigma fx is equal to 95.01. Now we are going to resolve all the forces vertically. So to resolve a force into its vertical component, magnitude of the force into sine angle made by the force with the horizontal. Now for a 200 Newton force, if you resolve it vertically, it will be acting upwards like this. So it will be 200 sine 45. A force acting vertically upwards is considered as positive. So 200 sine 45 is considered as positive. If you take this 400 Newton force and if you resolve it vertically, so it will also be acting upwards. So it will be 400 sine 30. If you resolve the 600 Newton force in the vertical direction, so it will be acting like this downwards. So it will be 600 sine 60. Since it's acting vertically downwards, it is considered as negative. So that's why it's minus 600 sine 60. Now if you sum all these three forces in the vertical direction, now you will get the vertical component, magnitude of the vertical component of the resultant sigma Fi equal to minus 178.2 Newton. Though this is step 2. So step 2, you have to resolve all the forces horizontally and find the sum of all the horizontal component of the forces, you get sigma Fx value. Second, you are going to resolve all the forces vertically. Now you are going to find the sum of all the vertical components, you get sigma Fy. Now the step 3 is you have to determine the magnitude of the resultant. How to determine the magnitude of the resultant? So it is given by the equation R is equal to sigma Fx square plus sigma Fy square root. So now you substitute the values you obtained for sigma Fx and sigma Fy here and square it and take the square root. You get the magnitude of the resultant as 201.95 Newton. Next step is you have to find the direction of the resultant. The direction of the resultant alpha is given by tan inverse of sigma Fy by Fx. Now when you substitute the sigma Fy and sigma Fx value, you need not put the minus sign or plus sign that is obtained during the resolving of the forces. It is sufficient if you put the number alone. So alpha is equal to tan inverse of sigma Fy, that is 178.2 divided by sigma Fx, it is 95.01. Now if you find this, you get the value of alpha as 61.93. Now I am going to represent this resultant magnitude and direction in the force system. Now since the Fx value is positive and Fy value is negative, so the resultant is going to be in the third quadrant. Sorry, it will be in the fourth quadrant. So R is equal to 201.95 acting at an angle of 61.93 degrees in the fourth quadrant. Now if you resolve this resultant, you will get Fx as positive and Fy as negative. So this is the methodology to determine the resultant of more than two coplanar concurrent forces acting at a point. Now we will go to a practical problem. I will read the problem. Two cables which have known tensions are attached to the top of a tower AB. So this is a tower AB. So on the top of a tower, two cables having tensions 25 kN and 40 kN are attached. Now a third cable AC is used as a guy wire. So this is a guy wire which is attached to this top of the tower, and the guy wire starts from A and it goes up to C. So this diagram is given in the problem. You have to determine the tension in the guy wire. You have to determine the tension in the guy wire, and the resultant of all these three forces, they are acting vertically downwards. That is what is given in the problem. If the resultant of the forces exerted by A by the three cables acts vertically downwards. So now there are three forces acting on the tower. Force at point A force of 40 kN and 25 kN are the two cables having the forces. The third cable is a guy wire and its force is unknown and it is named as T. The resultant of all these three forces are acting vertically downwards, and the distances are given, that is BC is given as 8 meters and the height of the tower is given as 12 meters. You have to determine the tension in the cable AC, that is in the guy wire AC. Now we are going to do this problem. Now since the resultant of all the forces are going to act vertically downwards, naturally the horizontal component of the resultant is going to be 0, because the resultant is having only a vertical component. So the horizontal component of the resultant is 0. So the vertical component of the resultant is going to be the magnitude of the resultant. So we can write, since the resultant is acting vertically downward, sigma Fx equal to 0 and sigma Fy equal to 0. Now we are going to determine the angle theta. How to determine the angle theta? Now you consider the triangle A, B and C. Now this forms a right angled triangle. Triangle ABC forms a right angled triangle. Now I am going to determine the value of theta. I am going to take tan theta. So now what is tan theta? Tan theta is nothing but opposite side by adjacent side. Now what is opposite side value? It is equal to 12 meters. What is the adjacent side value? It is 8 meters. So tan theta is equal to 12 by 8. So from that theta equal to tan inverse of 12 by 8. So from that you can find the value of theta. Theta is equal to 56.30 degrees. Now we have determined the value of theta. Now from the geometry of this figure, if the angle is theta here, then naturally this angle will also be theta. This is from the geometry of the figure. Now you resolve all the forces horizontally. So if you resolve all the forces horizontally, sigma Fx is equal to, if you take the 25 force, 25 cos 10. So 25 cos 10, the force is going to act towards right. So 25 cos 10 is positive. Now if you take this 40 kN force, 40 cos 20, if you resolve it horizontally, 40 into cos of angle made by the force with the horizontal, it is 20. Now this force is going to be acting towards the left, so it is minus. Now if you resolve the tension, T cos 56.30, if you resolve the force horizontally, this T will be T cos 56.30 acting towards the right. So this is also positive. Now you find the sum of all these three. Since the horizontal component of the resultant is 0, 0 equal to 25 cos 10 minus 40 cos 20 plus T cos 56.30. So from this you can find the tension. So the value of tension is obtained as 23.35 Newton. So I think you might have clearly understood how to apply this concept of resultant to determine the magnitude and direction of the resultant. Now we apply the concept of this resolving the forces to determine the magnitude and direction of the result. I hope you have understood the two problems which I have taken in this particular lecture. If you have any doubts or clarifications required, you can post it in the comment section. For more interesting lectures, please do like and subscribe. Thank you.